Okay, guys, so if you're watching this, then you're school studying polynomials, and you're probably not enjoying them too much, but I called this fun polynomials, we'll put that in quotes, because these are more exciting than your other polynomials. Now, a polynomial is anything that can be expressed as x to an nth power. So this could be x to the first, which you've done before. Those are just lines. X squared, those are polynomials. X to the third, fourth, fifth, so on and so forth. And they can do interesting things when you sketch them out. Now, for this video, I want to focus on how to get the equation of something like this. And it's really not difficult at all. You just need to think about three things. You need to think about the zeros. The zeros are also known as the x-intercepts. You need to think about multiplicity, which I'll explain in just a second. Multiplicity. Let's see if I can spell it first. And then let's focus on end behavior. Okay, so you may have heard these terms, but you may not know how to apply it to something like this. So the first thing I always do is look at my x-intercepts and where I'm crossing the graph. Now, right here, 1, 2, 3, 4. So at -4, I am crossing through the graph. Now, when you actually cross through the axis right there, that is said to have a multiplicity of 1. Okay, multiplicity just means how many times is -4 a factor, and by crossing through you can automatically assume 1. So you would start your equation by doing the factor that comes from -4, and if -4 is the solution, then the factor that it came from is x plus 4. It's always going to be the opposite sign of what you have here. Now the next one, I'm just going to go left to right. The next one is right here, okay, at -1. Now notice something interesting at -1, guys, is that we don't actually go through the x-axis. We do what's called a bounce or a touch. And if you bounce off the axis, that is usually a multiplicity of 2. And what that means, so if this is a -1, I need to have x plus 1 here. And a multiplicity of 2 just means that I'm going to put that squared on the factor. And there's all kinds of algebraic reasoning as to why this works, but it's easier just to memorize. If it goes through, it's an odd exponent, and if it bounces, it's an even exponent. And then this one over here, 1, 2, 3, 4. So if we cross through at 4, I'm going to do x minus 4, and I'm not going to put an exponent on it. I'm just going to leave it as a 1 because this looks like a multiplicity of 1. Now you may be saying, how did I know it was a 2 here instead of a 4 or a 6? Because maybe it was another even number. Or here I left this as a 1, but it could have been any odd number. And the way that I know is by the behavior of the graph. If you cross through something and it's pretty straightforward, it's going to be a 1, okay? The thing that would make this a different odd number other than 1 is if it started to cross through, but it like flattened out and then crossed. So if you see a flatten and cross, we'll just make a side note, a flatten when you cross, then it's most likely a multiplicity of 3. Now the more it flattens, maybe the bigger that odd number would be. The same thing would go if you flatten when you bounce or touch. It's probably a multiplicity of 4 or higher. So it's more about the even and the odd, and usually for your age you will see it going through pretty nicely. But keep these in mind. I always put these as a bonus on my pre-cal tests. Okay, so once I've analyzed the zeros, check, I'm going to move on, and actually we just talked multiplicity, so I'm done with that. We need to look at our end behavior, because end behavior just means what's happening on the left, what's happening on the right. Well, this is going down on the left and down on the right, and normally a graph that's doing that has been reflected. So you're probably going to want to put a negative out in the front of everything because it's facing down. So there's just little things that you're supposed to know from algebra, and as a quick refresher, if you're doing like x squared, we all know what x squared looks like. It's usually going up on both sides. But if I did a negative x squared, it would go down on both sides. So any even exponent is going to share these same properties, okay? What about x to the third? Well, if you know the parent for x to the third, it goes down on the left and up on the right. So some teachers would write that as x is approaching negative infinity, okay? Y is approaching, well, it's going down, so negative infinity. And then on this side, as x is approaching positive infinity, so as the x's are getting bigger and bigger and bigger, the y's are also getting bigger and bigger and bigger. That might be the answer for end behavior. But what if I made that x cubed negative? Then it's going to flip. And the exact opposite's going to be true. So any odd exponent is going to share these same properties. So you don't have to memorize a huge chart, just know what x squared looks like, know what x cubed looks like, and then understand that if you see a negative in front of it, guys, it's just going to flip it around. Okay? So there is the beginnings of polynomials. Now, if you weren't given a graph, if instead you were given an equation like the following, like this, and maybe you were asked to find the zeros and the multiplicity. Okay, the multiplicity of each zero. So in order to find the zeros or the factors, you're going to have to factor it. So I would look up here and notice that I can take an x out of every one, and when I take that x out, this is what I'm dealing with. And it may feel at first like it's hard to factor, and I get that, but anytime these are in the ratio of 2 to 1, if this one's twice as much as this one, then you can pretend it's a quadratic and do this kind of factoring. So let's think of two numbers that multiply to negative 18, but add to make a negative 7. How about like 9 and 2? So which one would need to be negative? Then that would need to be negative to make a negative 7. Okay, so in the front, instead of just putting x, it just means there's an x squared in the front of each of these. Now, if this factors down any more, keep going, and sadly it does, guys. We're not finished yet, okay? Bring down that x. This is a difference of squares, so now I can do this. Now, why can't I do the same here? Well, I can't because that's not a minus, so that just stays the same. All right, now that I have this, what does that mean? Okay, now that I have this, this is what we can look at for our factors. And notice that nobody repeats. Do y'all see that? Nobody repeats. So they all have a multiplicity of 1. If somebody repeated, however many times it would repeat would be its multiplicity. All right, so let me know if there's another one you come across that either you can't factor, or maybe you factor it and you're not sure what you're looking at. And then I can help you out. But that's pretty much all that is. And then if we had to graph it, you know, just as a bonus, then our zeros would be, if we set this to 0, we get 0. If we set this to 0, we get negative 3. If we set this to 0, we get positive 3. Now, if we set this to 0, it's not going to work, because you're going to end up taking the square root of a negative number, and you're going to get imaginary numbers. So if you get imaginary numbers, they cannot be graphed. They're not real, so they can't go here. So these are the only x-intercepts, and if we wanted to look at our end behavior from before, this is an x to the 5th graph, which means it's odd, so I know it's going to go down on this side and up on this side because it matches the cubic parent. And now I can just play connect the dots. There we go. Now, as far as how high this goes and how low this goes, that's a big old question mark for now. And depending on your pre-cal teacher, they'll either show you how to find that min and max, or they'll just say, who cares, just guess it and sketch the curve. And they're really looking for, do you know what the arrows are doing on the left and the right? Do you know where it crosses the axis? And then they'll be happy. So good luck. I hope that gives you a good start.